Okay, so today's lesson is on graphing hyperbolas and finding the foci or focal points for hyperbolas. And so you'll notice looking at the two equations that are here, the equations look very similar to equations of ellipses. Okay, what's the difference between the equation of a hyperbola and the equation of an ellipse?
Subtraction.
Yeah, just the subtraction. That's the only difference, is that we have subtraction. And since there is subtraction, changing the order makes a difference. When we have the x term in front, the x term is positive, then the hyperbola goes in the x direction, or along the x-axis. When the y is in front and positive, then the hyperbola goes in the y direction. And then to find the focal points are always inside the hyperbola, so meaning that the curve wraps around the focal points. So to find the distance from the center to the focus, we use c squared equals a squared plus b squared, in contrast to parabolas in contrast to ellipses. Ellipses, we did c squared equals a squared minus b squared, and then so for hyperbolas it's a squared plus b squared. And so that distance c is the distance from the center to the focal point. And then the same thing would be true here if this was the center. From the center to the focal point would be a distance of c. And then I'll walk you through the steps for graphing. Any questions on the equations in general? Okay, so for the graph, the process starts off similar to graphing an ellipse. So first we need to identify the center.
2, -3.
2, -3 is correct. So 2 in the x direction, -3 in the y direction. So there's our center. And then just like an ellipse, the number underneath x tells us how far to move in the x direction from the center. And so since 16 is 4 squared, we're going to move 4 to the right and 4 to the left. And the number underneath y tells us how far to move in the y direction. So 4 squared is 2, so we're going to move 2 in the y direction up and 2 down. And if this was an ellipse, we would go ahead and draw the ellipse through those points. Okay, but now we're not drawing an ellipse, we're drawing a hyperbola. So instead of an ellipse, what we're going to do is we're going to put a box there, a dotted box with the same dimensions. And that's going to serve as guidelines for our asymptotes. Okay, so once you have the box drawn, we want to draw asymptotes through the corners. You're welcome. So use calculators on that. Okay, so the asymptotes are not actually part of the hyperbola. They help us guide the shape of the hyperbola. And so the hyperbola, since x is first and that's the positive term, it's going to go in the x direction. So our vertices are going to be right here on the edge of the box, and then it's going to curve toward the asymptotes. Okay, so the red graph is the hyperbola itself. The blue, all the blue marks that you see are just guidelines for the hyperbola, but the red graph is the actual hyperbola. Okay, and now we're ready to find the foci. So c squared is equal to a squared plus b squared. So c squared equals 20, which means c equals 2 root 5. Square root of 20 is 2 root 5. And 2 root 5 is about 4.5. And so that tells us how far to go from the center. So if I go to the center of the hyperbola and I go over 1, 2, 3, 4.5, that puts me right about here. And when I write the coordinates, I'm not going to use the decimal approximation, I'm going to use the actual value. So I was at an x value of 2, and I moved over to the right 2 root 5, so that's 2 plus 2 root 5. And the y coordinate hasn't changed, it's still negative 3.
Why did you do 4 plus 2 root 5?
And then
4 plus
the x coordinate is 2, and I'm moving to the right by a value of c, which is 2.5. I mean 2 root 5.
okay.
And then the same thing going to the left. I'd go to the left about 4.5 units, which puts me at about negative 2.5. The coordinates would be 2 minus 2 root 5, negative 3. And so I have the focal points identified. Now we've drawn the asymptotes, but we didn't write the equations. So the equations of the asymptotes are pretty easy to write once we know the slope. And so if you look at the box, the dotted box makes it real easy to find the slope. I'm going up 2 and over 4. So rise over run, 2 over 4. The slope of this asymptote would be 2 over 4, which is 1/2, which means the slope of this asymptote would be negative 1/2. And so now we can use the point slope form. We know those lines both go through the same point. They both go through the point 2, negative 3. The center point was 2, negative 3. So the equation of one asymptote would be y plus 3 equals 1/2 x minus 2. That's using point slope form. I plugged in the point 2, negative 3, and I plugged in the slope 1/2. And then for the other one, it would be y plus 3 equals negative 1/2 of x minus 2. If you prefer, you can always write those in slope-intercept form, but it's not required. This first one would be y equals 1/2 x minus 4, and the second one would be y equals negative 1/2 x minus 2. So either one, either the point slope form or slope intercept form is fine. Okay, any questions on that one? Okay, so I'd like you to go ahead and try this one.
Oh, wait. 5 over 3. Oh. And negative 5.
Okay, so our center is at negative 1, 2. And then we're going to go 5 in the y direction, because 25 is 5 squared, so we go 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And then underneath x is 3 squared, so we go 1, 2, 3, 1, 2, 3. Draw our box. Okay, now we're ready to draw our asymptotes. Okay, now we're ready to draw the hyperbola, the vertices. Since y is the since the y squared is the positive term, it's going to go in the y direction. And now we can find our focal points. C squared is equal to a squared plus b squared, which is 34. So c is the square root of 34, which is almost 6. I think it's about 5.8 from the center. And so the coordinates of the focal points, we're at a y value of 2, and then we're going to add root 34. We're at an x value of -1. So -1, comma 2 plus root 34. This one's going to be -1, comma 2 minus square root of 34. And then the equations of the asymptotes, they both go through the point -1, 2, and the slopes are plus and minus 5/3. And so the equations are going to be y minus 2 equals 5/3 x plus 1, and y minus 2 equals -5/3 x plus 1. Any questions on those? Okay, so we have one more to do. This one, we're given the equation of a hyperbola, but we can hardly even recognize that it's a hyperbola. So we need to first put it in the standard form for a hyperbola so we can graph it more easily. So first I want to get the x parts together. We have -4x squared and -24x. So I could start off by factoring out a -4, and that would leave me with x squared plus 6x. I'm going to complete the square there. And then I have y squared minus 4y plus blank to complete the square. And then I'm going to move the 36 to the other side for now, and I'm going to leave space for the two numbers that we're going to add to both sides. So we're just completing the square to try to get it in the standard form.
Wait, does it equal 9?
So what do I need to fill in the first blank to complete the square?
9.
9. And so should I add 9 to both sides?
Yes.
So adding 9 to both sides is not correct because it's been multiplied by -4, so it's actually adding 36 to both sides, a -36 to both sides. So even though we put 9 there, that really made a -36 on the left side that didn't used to be there. Okay? And then to fill in the next blank, half of -4, it's -2 squared is 4, so I add 4 to both sides. Now we have -4 times x plus 3 squared, and y minus 2 squared equals 4. And remember, we want to try to get it in the form for a hyperbola, so we want the right side to equal 1. So I'm going to divide both sides by 4. And this first term is negative, so we should switch these. So it's going to be y minus 2 squared over 4 minus x plus 3 squared. Now, we don't really have to put a 1 in the bottom, but by putting a 1 in the bottom, that helps us identify what a and b are. So that makes it a little bit easier to graph. And if we wanted to find the foci, it's easier to have a number in the denominator. So you can always put a 1 there if there's nothing there. And then that's equal to 1. So what's the center? Negative 3, 2. And in the y direction, we're going to go 2 units. In the x direction, we're going to go 1 unit each way. And now we can draw our asymptotes through the corners. And since the y squared is the positive term, it's going to go in the y direction again. And that's it. It just said graph the hyperbola. So there's our graph, the solid blue. Okay, any questions?
How do you complete the square quickly?
So we're taking half of the middle term, half of b. So half of 6 is 3. Square it. You get 9. So that's what we add to both sides. Take half of negative 4, negative 2, square it, you get 4. Any other questions?